Hi, everyone. I'm Rosemary Coates at the Reshoring Institute. We are a nonprofit and nonpartisan organization that helps companies bring manufacturing back to the U.S. Today, I'm very excited to have my guest, Guy Letendre from UAMI. That's the Utah Advanced Materials and Manufacturing Initiative. He's going to tell us about advanced materials in manufacturing. So welcome, Guy.
Oh, thank you. How are you today, Rosemary?
I'm good. How are you?
Excellent. Thank you very much.
Good. Hey, Guy, let's start off by you telling us a little bit about your background. I know you've been in manufacturing and the business world for a long, long time. Can you give us a little bit of history?
Yes. So I got a mechanical engineering degree from Washington State University. And my first real career was in rocket motors, little small rocket motors that eventually evolved into making airbag inflators for a company called Autoliv, which is the largest automotive safety company in the world. I started there as an engineer, ended up leaving there as vice president of engineering. But during my tenure there, I managed a factory in Amsterdam and one of the largest prototype engineering facilities in the United States. In fact, one of the only engineering groups to win a Shingle Prize for manufacturing excellence. And then I left Autoliv and worked in the pharma space and solar engineering and high power electronics in various roles from CFO, COO, and international business development. So bringing operation acumen, some engineering, business development, and finance, I've kind of covered a lot of the main aspects of a business and joined UAMI about 2 years ago to help small businesses and large businesses grow in their business, but largely businesses in the advanced manufacturing space, which is, some people consider that additive manufacturing and composites, but also as companies employ artificial intelligence and robotics and move their companies forward. We're seeing that more jobs are coming back to the United States as our manufacturing technologies are reducing the dependence on unskilled labor, so to speak, to grow our economy and become, economically independent.
That's terrific. So that's exactly where I want to go. I want to talk about these advanced materials and the way UAMI is introducing these materials to companies that can then use them to build products in the U.S. that are competitive in the world market. So give us a little bit of background about UAMI. It's kind of a funny name, and tell us about what you do and what it's all about.
So UAMI was started by a couple of visionaries in 2016 that wanted to grow this industry ecosystem in Utah. Largely started around composites. Utah has a large composites history. Hexcel, Northrop Grumman, Hercules, Thiokol are all big names in composites for national defense, world leaders in a lot of these things. And we wanted to take advantage of those companies and the history and the technology that we have here and spread that out to smaller companies. And now we have bicycle companies, archery companies, and smaller companies doing composites here in Utah for aircraft, sporting goods, automotive, things like that for composites. But our advanced manufacturing also includes additive manufacturing or 3D printing. And we actually have a company in here in Utah called Merit 3D. They make millions of parts using 3D printing. Now, we've seen people do 3D printing for making prototypes and one-of-a-kinds, onesie-twosies, but this is one of the first companies that uses additive manufacturing in manufacturing. And they got started in this because they were a sister company made vacuum cleaners and they couldn't get their parts from China. So they started 3D printing them. So they reshored using 3D printing instead of traditional molds to reduce cycle time from when they have an idea to when you can start production and reduce tooling costs. Now, molding is very expensive and it has its place in industry, but they're doing really well making parts using additive manufacturing and reshoring at the same time.
That's wonderful news. That's great news. Why Utah? I think there's a long background in aerospace in Utah in particular, and being close to a military base. But are there other reasons why Utah? Is it a source for materials, or is it just that's where the engineers were to start the company?
Well, when you talk about materials themselves, there are a lot of critical materials and starting materials here in Utah. If you go really deep into the supply chain, the lithiums, the cobalts, the vanadiums, the neodymiums, and those are all in Utah. But from an advanced manufacturing, which takes these materials, carbon fiber, for example, and moves them forward, a lot of it depends on engineering talent and capital, and steeped in history since the 50s. The first composite rocket motors were developed here in Utah. So there's a lot of history here. As you mentioned, Hill Air Force Base is here, and they maintain all the fighter planes here, the F-16, the F-35, the F-22. And the new Sentinel program is also in Utah, which is the next generation of Minuteman for our national security. It's also a state where we don't have our unemployment rate in Utah is lower than 3% right now. So in order to grow our economy, we have to grow our economy with advanced manufacturing. We're not going to grow it with unskilled work. We just don't have really any unskilled work population
That's
here
a
in Utah. So we have to move
that's
forward
a
in a
really
smart
yeah.
way.
And that's a really important point because we have a labor shortage all across America, not only in the trucking industry, but in manufacturing overall. We just, if anyone wants a job, they can probably get a job now. There's essentially full employment. So if we're going to grow manufacturing, and we know there's a big manufacturing super cycle that started, the growth rates are just perspective, or the prospects are that they will skyrocket in terms of growth. And if that's the case, then we need to figure out how we're going to do that, because there just aren't enough people. So this advanced manufacturing is really important. I want to just take a few minutes though to explore what are composites, because for a long time I was under the impression they were 3D printing of metal products, but they're not actually metal, right? They're petroleum products. Is that right?
Well, the term composite, there's the technical term of composite and what industry thinks of when we say composites. Composites started back in the early days when people put straw and clay together, and what the straw would do was help the clay stick together, and then the clay helped the straw kind of stick together. So straw and clay or adobe is kind of the first use of composites. So you use what's called a matrix or a glue or something that holds fibers together. Concrete and rebar is a composite where the rebar adds strength to the concrete. Today, we think of fiberglass boats are composites. So you have fiberglass, which is long strings of glass that have strength, and then you have glue that holds the fiberglass together to make a boat. Modern composites are carbon fiber composites, and those are today traditionally petroleum products. So they take a nylon or it's pan, and it's a resin, and then they carbonize it. They put it in a furnace, and then it gets rid of all the non-carbon molecules, and then they graphitize it, which is another super hot furnacing operation with these fibers, and it lines the molecules up to be super strong. And so a carbon fiber looks like threads, very thin threads. And when you put a lot of them together, you get what's called a tow or a yarn looking thing. And you can weave these yarns into fabrics, or you can put them on a robot and the robot can take these tows and place them around like additive manufacturing, or wind a bottle for a composite gas bottle that you might see for natural gas tanks or hydrogen tanks. And then the carbon fiber also needs a glue or a resin system to hold them together. And so there's multiple manufacturing technologies for composites today. You can weave it into cloth and lay different layers of cloth together to make like a wing of an airplane. You can wind it around a bottle to strengthen a high pressure gas bottle. There's robotics now that you can make 3D parts using additive manufacturing with carbon fiber. The challenge with carbon fiber products today is the current technologies that are mainly deployed are either very labor intensive, like for airplane wings, or not very fast. And so automotive hasn't really adopted carbon fiber yet. And so the laboratories and companies now are working in advancing manufacturing technologies to use carbon fiber in different ways, injection molding or bulk molding compound technologies to reduce the cycle time so that, if you make 1 million cars a year, your cycle time for a part has to be less than 3 minutes, or it's not really
And
economic.
so it's my understanding that the carbon fibers are super, super strong and very lightweight. So even stronger than metals, right?
Yeah, and
So
so that's,
so
yep.
So if that's the case, there must be a lot of uses, not just aircraft, obviously, because they're always looking for lighter weight materials, but automotive as well. They're always looking for lighter component parts so that the weight of the vehicle is lighter, which improves the fuel economy, right? And if they're stronger and they're crash resistant, that sort of thing, there are all kinds of good reasons why this particular material would be very interesting in the automotive sector. In trucking also, I would think that, chassis and things like that have carbon fiber like this, components that are um, that are put together that are super strong but still lightweight is going to facilitate weight loads, heavy loads that are transported across the nation. So this is really interesting in terms of advanced materials. I know you said there's aircraft and some other small uses, but there must be research going on for a lot of different industries. Is that right?
That's right. So for automotive, as I mentioned today, while carbon fiber itself is relatively expensive, it's like 8 to 12 or more. You can pay hundreds of dollars a pound depending on what specialty of fiber you need. But let's say it's $10 a pound. That's pretty expensive compared to fiberglass, which is $1 a pound. And so you really need extra performance requirements in order to want to use carbon fiber, or you need to reduce the cost of using that manufacturing technique. I forgot the name of the company, and I apologize for that, but there is a company in the Midwest working on a trailer using composites. And composites also have lower thermal conductivity. So a refrigerator trailer would be lighter, which would reduce fuel consumption, and would have thermal transfer properties much better than aluminum or steel, such that then a reefer trailer would use even less energy to keep it cold and a lighter vehicle. And I apologize, I don't remember the name for that company, but your audience can Google that. And that's, to your point, there are people in the trucking industry looking at reducing the weight and the efficiency of their trailers.
Yeah, absolutely. So, I mean, it just sounds like a winning combination, a stronger kind of material, that is capable of being manufactured, lighter weight, which improves fuel economy, probably less pollution in developing the materials. I mean, there's all kinds of reasons why it's good. Now we just have to get the costs down, right?
Yep. It's all about cost.
Yeah, for sure. So I know UAMI is focused on Utah manufacturing, but do you serve nationwide also? If a company came to you, say from New Jersey, and said they wanted help in developing a new product, is that something you would do?
Yeah, we're largely supported by the state of Utah, but we also have grants from the federal grant, from the DoD, the EDA, and the SBA. And nothing makes us happier than to help all types of companies. We do have a good group of STEM experts that help companies with technical questions around composites and advanced materials, and we would love to help companies. a real strong thing that we do is introduce people to other people. So we have a national presence, and we go to the conferences, and we have a lot of respected partners like IACME, which is a national institute from the Department of Energy, and things like that. So yeah, if a company wanted help with advanced manufacturing, they should give us a call. And if we don't know the answer, we know who does, and we'd love to help them out.
So you actually take public and private funds then for development, is that correct? Are any of the new bills going to give you funds? Any of the Inflation Reduction Act or the Chips and Sciences Act or the Infrastructure Act? Will any of those provide funding for UAMI or for the kind of research that you're doing in composites?
Not necessarily the funds will go to UAMI, but we're helping a lot of our partner companies apply for funds. So right now we're working with two companies on a critical minerals proposal that's being funded through the Department of Energy. There's funds that are going through EDA and SBA and those large bills that we're helping companies apply for as well. So that it doesn't necessarily come to UAMI as much as UAMI is aware of these grant opportunities. We make our partner companies aware of them. We help them with their grants, give them technical advice or philosophical advice on how to apply for these grants. And then when they win them, then we help them, execute them to be successful with their grants.
Yeah, I'm on your mailing list, so I know you do a lot of events. Can you talk about some of those events that you offer that are open to the public if someone's interested?
Yeah, so we do, I would say, two types of events. We do large events called Crosstalk that we have 3 of those a year. One's in the spring, and we partner with SAMPI, which is a Advanced Materials Processing National Organization. We have that here in Utah. It's very STEM focused on advanced materials, composites, and processing. So that's really STEM related, and that's in Salt Lake City in March 20th this year. And then we have another Crosstalk event in May that's targeting around small businesses getting into the aerospace and defense community. So we have a lot of speakers that are from the Air Force, Department of Defense, and then regional entities like UAMI that help small businesses be successful. And we have small businesses present their own technologies at these crosstalks to help with the networking. So a lot of these events are largely networking oriented, but also, informational. And then in the fall, we just finished our critical materials event in Price, Utah. Speakers there, a lot from the Department of Energy and companies that are experts in critical minerals like lithium, batteries, battery technologies, things like that, to grow our Eastern Utah economy as the dependence on coal is diminishing. These communities also have a core competence in mineral processing and mineral extraction. And given that 90% of our critical materials do not come from the United States, there's a real opportunity to move our rural communities to get in the critical materials industry.
Yeah, for sure. So it's my understanding that about 80 to 85% of the rare earth minerals are coming from China right now. Not that these minerals aren't found everywhere, but the processing part of it is very difficult and pollutes the environment. And even China is processing these minerals up along the Mongolian border in the middle of nowhere because there's so much pollution associated with it. But if China decides to cut off our supply of rare earth elements, we are in bad trouble because they are in every electronics device, all defense devices, all kinds of things require these kind of minerals. They go into electronics, into magnets, into things that are industrial products and essential to building products. So yeah, it's time that we redevelop that whole mining operation in the U.S. so we're not so dependent on foreign imports. I know you also support Connects. I always like to call it Connex, but I think it's Connects.
Yep.
which is a startup, sort of. I think they've been around for a while now, but they were originally started in Utah. That is an interesting platform for suppliers to meet and come together. Can you talk to us a little bit about your support for Connects?
Yes, so I think 4 years ago, a lot of our composite industry members like Northrop Grumman, Hexcel, and other Boeing is General Atomics. A lot of these companies were buying services and materials outside of the state, and when the state UAMI went to them, that's our mission is to grow the ecosystem in the state. So why are you buying so much from out of state? And they said, we don't know what technologies and what companies are in the state of Utah right now. How can we get a better handle on that? So UAMI hired a software company, and we went out and we found all these suppliers in the composites industry in Utah. And instead of just putting their company name into the database that was created, we focused on looking at what technologies and process capabilities he had to be more precise to what types of work they can do and less precise on what products they might make. So today, if you wanted to Google white zirconium, you might find companies that sell white zirconium. But if you don't find a supplier that makes white zirconium, if you know how to make white zirconium, you can say, oh, I need these processes in a company. So the searching is on process capability more than it is on products. So as a company, if you want someone that does molding or spray drying or extruding, and you know what kind of extruder this company might need to make your product, that would be in the database. So from a supply chain perspective, it's more powerful to develop a supply chain knowing what capabilities the suppliers have than it is to search on what types of products they make. And that was
I think this is so important because as manufacturing was offshoring to China, basically in the early 2000s, all the way through about 2015 when it started to reverse a little bit. But as all of that manufacturing was going overseas, so were the suppliers. So in today's environment, if you want to bring manufacturing back, it's quite possible you won't have suppliers in the US. They have to be redeveloped. So a platform like this, that where you can go and say, I need, well, we had a client that needed white lithium grease. I had no idea what it was, but really difficult to find. And there were no manufacturers left in the US. So we had to go and look for manufacturers that were capable of producing it and then work with them to redevelop the production of this particular commodity. And I think that's the beauty of Connex, is it allows for those kind of connections. I heard there was a famous story too, where Connex connected a supplier with a manufacturer that was right down the street. They didn't know each other. They didn't know that this supplier could produce the goods that were required at the manufacturer, and they just hooked them up and they were ready to go, which is just fantastic. This is a problem with these small manufacturers trying to get the word out that they're capable of doing things, right?
Yeah, and in a lot of these tools, you need both sides. You need people to enter their own capability. And a lot of these suppliers are entering the database, their information, hoping that a customer will find them. But eventually they find out that they need suppliers too. And so everyone wins with this database. And it's been very popular with ME manufacturing extension partnership offices are the ones that are taking down the initial license in each state so that their manufacturers can have access to the information themselves. So if you're in the audience today, look up your local MEP office and ask them about Connects, and they can hook you up to access to the database.
Guy, this has been so interesting. I really appreciate your time today and helping us understand a little bit more about the services that you offer at UAMI, as well as the potential opportunity for Connects and putting suppliers and manufacturers together for the future of composites in the in the world. I think we're going to see more and more of those as time goes on. So thank you again for joining me as a guest today. Really appreciate it, and have a great day.
Thank you, Rosemary. It was really nice to talk to you.